Time to talk about ionic bonds and ionic compounds. Ionic bonds form when a metal cation is attracted to a non-metal anion. This attraction is the result of a transfer of electrons from the metal to the non-metal. Remember, cations are positive and anions are negative. An alternating pattern of cations and anions forms an ionic compound. While we are on the subject of ions, it may be worthwhile to point out a special type of ion, one that is made up of two or more covalently bonded atoms. These ions are called polyatomic ions. The prefix poly means many, hence polyatomic means many atoms. A polyatomic ion is a charged substance composed of many atoms. Ionic bonds form due to the formation of ions creating oppositely charged particles that are then attracted to each other. Let's look at an example using calcium, which is a metal. I know that because calcium is on the left side of the periodic table. And oxygen, which is a nonmetal, because it's on the right side of the periodic table. Since calcium is an alkaline earth metal in group 2, I know calcium atoms have 2 valence electrons. Therefore, the electron dot diagram would be the symbol Ca surrounded by 2 dots. My periodic table also informs me that a neutral atom of calcium would contain 20 protons and 20 electrons. Since calcium is a metal, I know it will lose 2 electrons when it forms an ion. Therefore, an ion of calcium would still have 20 protons, but it will only have 18 electrons. That is how the atom achieves a 2+ charge. Electron dot diagrams for cations are really easy to draw. Since the metal lost all of its valence electrons, the diagram is simply the symbol for the ion, Ca2+ in this case. When forming an ion, calcium atoms lose 2 electrons. By losing these 2 electrons, they achieve the same number of electrons as argon. Look at your periodic table. Both argon and the calcium atom have 18 electrons. Remember, the whole point of bonding, or forming an ion in this case, is for an atom to achieve a valence shell of a noble gas. Calcium atoms achieve that by losing 2 electrons. Now let's look at the nonmetal oxygen. Oxygen is in group 6, so I know oxygen atoms have 6 valence electrons. The electron dot structure of oxygen is an O surrounded by 6 dots. Using my periodic table, I know a neutral atom of oxygen has 8 protons and 8 electrons. Since oxygen is a nonmetal, I know it will gain 2 electrons when it forms an ion. That means an oxygen anion would still have 8 protons, but it will have 10 electrons. That is how the atom gets its 2- charge. Electron dot structures for anions aren't too hard to draw either. Since the nonmetal gains enough electrons to achieve 8 valence electrons, the structure for an anion is always the symbol of the anion, surrounded by 8 dots. Just one slight difference. I like to use a different symbol for the electrons that the atom gains. So here I used X's instead of dots to represent the 2 electrons that an oxygen atom will gain to form an ion. When forming an ion, oxygen atoms will gain 2 electrons. By gaining these 2 electrons, they achieve the same number of electrons as neon. Check it out. Both neon and oxygen ions have 10 electrons. Oxygen atoms gain 2 electrons in order to have a full valence shell similar to neon. Last unit, I had you graph the trend of ionization energy on the periodic table. Once again, ionization energy is the energy required to remove an electron from an atom. We also talked about the trend of atomic radius that is seen here. You can see that the atomic radius decreases across the period and increases down a group or family. These 2 trends are actually closely related. When the atomic radius is smaller, that means the negative electrons are closer to the positive nucleus. The force of attraction between the electrons and the nucleus is stronger when those 2 particles are closer together. Hopefully, this helps you understand why metals lose electrons much easier than nonmetals. Because metal atoms are larger, The electrons in a metal are further away from the positive nucleus. Therefore, the force of attraction between the positive nucleus and the negative electrons is not as great, which makes removing the electron much easier for a metal. Just as we saw when we graphed the trend, ionization energy increases as you move across the period. Smaller atoms mean more energy is required to overcome the force of attraction. Ionization energy decreases down a group. Larger atoms means less energy is required to remove an electron. Let's talk about naming ions. First off, don't forget cations are positive. That's right, they're positive. Cations form when metals lose electrons. The name for a cation is the same as the name of the element. Na is sodium. Na plus is also sodium. Anions form when nonmetals gain electrons. To name an anion, you change the ending of the element name to IDE. Cl is the element chlorine. The anion, Cl minus, is called chloride. I think we should practice that and some more electron dot structures while we are at it. The symbol for potassium is K. Since potassium is an alkali metal in group 1, I know it has one valence electron, so just one dot. Metals lose electrons, so potassium will lose that one valence electron to become a K plus cation. The name of a cation is the same as the name of the element, so K plus is still potassium. I'll help you with one more. S is the symbol for sulfur. Sulfur is in group 6, so I will represent its 6 valence electrons with 6 dots around the symbol. Instead of losing 6 electrons, this nonmetal will gain 2 electrons to fill its valence shell. That means sulfur will form a 2 minus anion. Since this is an anion, I must use an IED ending to change the name of the element. In this case, drop the UR ending. Sulfur becomes sulfide. All right, it's your turn. Pause the video and attempt the other 4 examples. Draw the electron dot structure, determine the ion, and then name it. You got this. Pause the video and try it out. Press play again after you have attempted them. Okay, how can electron dot structures help us to visualize the formation of an ionic bond? Let's stick with the example using calcium and oxygen. Start with the electron dot structures of both elements. Ca with 2 dots and O with 6 dots. Ionic bonds form due to a transfer of electrons from the metal to the nonmetal. The whole point of forming a bond is for both atoms to achieve a full valence shell of 8 electrons. Calcium atoms can achieve this by getting rid of these 2 valence electrons. Oxygen atoms can achieve this by gaining 2 more valence electrons. Well, this works out perfectly. Calcium can transfer its 2 valence electrons to oxygen. When that happens, calcium becomes a 2 plus cation and oxygen becomes a 2 minus anion. The oppositely charged ions are then naturally attracted to each other and an ionic bond forms. Man, I love chemistry. Ionic substances form a repeating pattern of oppositely charged ions called a crystal lattice. If this purple ion is a cation, then next to it would be an anion, then a cation, then an anion, and then you get the picture. Because ionic substances are actually a repeating pattern of ions, they don't fit the definition of a molecule, 2 or more atoms bonded together. Ionic substances, which are attractions between a metal and a nonmetal, are only classified as ionic compounds. Being able to identify an ionic compound will be important as we move forward. To become a pro at this, all you need is your periodic table. Ionic compounds form when a metal from the left side of the periodic table bonds with a nonmetal from the right side of the periodic table. Finally, what are the properties of ionic compounds? Because of the strong attraction between oppositely charged ions, ionic compounds tend to have high melting points. In fact, the melting point for lead bromide, shown here, is actually on the low side. In their solid forms, ionic compounds are not good conductors. However, if you melt or dissolve the solid, ionic substances become excellent conductors. This is because as a liquid, or when dissolved, the ions break free from the lattice structure. Free-flowing charged particles naturally conduct electricity very well. Ionic compounds tend to be brittle because of the way the ions stack together. The ions can slide very easily when a force is applied, and then repulsive forces push the solid apart. Many ionic compounds are soluble in water. Think table salt. Water molecules interact very well with charged particles, which means water is excellent at breaking apart the crystal lattice structure. As always, I just threw a bunch of information at you. I should probably give you some time to process. So until next time.